Okay, we have two simultaneous speakers for you today. Okay, for this session. Please welcome Wenzi and also Fish Kong, both applications engineers from CBS CADVision Systems. All right, so I'll just leave it to them right now.
Hello, can you hear me?
Hello. Hi.
Can you see my
All
screen?
right.
Yeah, I will share my screen now. Anyone can see my screen? JJ, can you
Not
see my
yet.
screen?
We're actually looking at a blue screen right now.
Oh, all right.
Please give me a minute.
Sure thing.
How about now?
Still the blue screen.
Where I'm making my setting. How about now?
Yep. What's new in
Okay.
SolidWorks Simulation 2021? All right. Yep. We see your screen right now.
Okay.
All right. I'm just gonna leave it to you, both of you. So have fun.
Okay.
Okay.
Right.
Thank you, JJ.
Okay. Okay. Thanks, JJ. So I will start my session. Okay. Hello, everyone. I will lead the guidance to bring all of you into the journey of what's new in SolidWorks Simulation and Flow Simulation 2021. And this is my colleague, Fish. Fish,
Hello.
how are you doing?
I'm fine, thank you.
Yeah. Okay. So I think because I am the one will be in charge in the simulation and the flow simulation, and Fish will be in the plastic and
3D experience simulations.
yes.
Yeah.
Okay. So first, I will go into my simulation part first. So in the new release, the SolidWorks simulation had made some changes regarding to the contact and the meshing process, which help to increase the study performance. So for instance, the faster contact and stabilization in contact setup, the mesh recognition tools, and the way of the software to choose the solver as well as change in the terminology in the software. So let's have a look into it now.
Okay.
In the new release, there are some added support for the multi-core processing and for both of the contacts and the meshing. After the setup process, you can mesh and run the study. With the improvement in the solver, user can now increase the accuracy of the result, and meanwhile, it reduces the solving time. So here, show the mesh details of the study, and for next, in this screen, it shows the total solution time. But what's led to the improvement of the simulation study? Let's take a closer look to see how Simulation 2021 has made this whole process easier. Okay. So the first exciting feature is the new properties for bond and contact interactions. This helps to specify the gap and stabilization regions to automatically make your study more robust even for the models with slightly imperfect geometry. From there, you can set out the study in a shorter time with minimal effort. For instance, the clearance between the board, nut, and the plate are automatically recognized and treated. This helps to save user from inaccurate results and time spent in troubleshooting. Also, another improvement in this new release is the mesh final state quality tools. And it was a new feature which is also my favorite in the entire update. Why? It is because with these useful tools, the user or you can detect the poor elements and automatically isolate it. Like this, making them quick and easy to find for modification. And this can save a lot of time for troubleshooting the problem. Also, the mesh helper also may be used to automate the mesh refinement if necessary. On the other hand, as we know, when it's come to solve the study, choosing a right solver can save a lot of calculation time and prevent some errors. In fact, the automatically selection of solver mechanism has been optimized to a better account for many variables to give you the best run for study and computer. Of course, for those experienced users, you can choose the suitable solver in your study manually. There's no problem about it. So there's another improvement and also the last improvement in SolidWorks Simulation 2021 that introduce a broad range of changes in terminology for context and component interaction. So the user interface is now matched the conventional industry terminology and have a better represent enhancement that you have seen here. So it will more easier to understand for those users. And what is the goal for the changes is to improve the clarity and have a better alignment through the terminology with the industry standard, so that the software will be easier to adapt for those designers and writers who never involved in SolidWorks simulation. Now we have understand the new feature in the SolidWorks 2021 simulation. So I will go into the SolidWorks flow simulation in the next session. In the new release of the SolidWorks flow, it has made some improvement in terms of the analysis process. For instance, a better visualization of flux plot energy balance, as well as the minimum and maximum value in the plot region. So in the new release, the rotating regions can be combined with the free surface feature, which is unable to be done previously. This helps a lot, and it expands the type of CFD problem to be solved. For this thruster, we have solving for the torque and power requirements where it interact with two separate grids concurrently. The goals are created to track this output, and by going to the history section of the goal for this one, the value can be viewed throughout the duration of the study. Also, with the SolidWorks Simulation 2021, the new cross in the summary table make it easier than ever to find the maximum value. This is my second favorite in the entire audit. As in previously, I have made some challenges to determine the type of maximum value occur. So also to create a common plots to visualize result is now even more efficient by using the new create plots from scenes command. You can even create the sense plot in a multiple project all at once. Just activate the plots to read them. If you create one or multiple plots that you want to use in other projects, simply show the desired plots and choose the new create scenes template option. With this, users can create their customized analyzed plot with only one command and have a better visualization of the result. So in another study, the heat analysis study, the flux plot provides a graphical interface so you can easily understand where it is coming from and where it's going. A new option in this plot groups all items by type, so you can quickly check the energy balance of simulation and ensure that your study has fully converged. Now, you can even have a better understanding on the behavior of heat flux during the analysis. In an actual study, normally we will plot based on a specific region, the emphasized region we want to know about the result. So, however, the maximum and minimum range of the plot will follow the global result. But now, in the new release, you can automatically define the plot for minimum and maximum. With this, you can clearly communicate the range of the value without further manual modification. Previously, when I want to determine a maximum value across a set of goals, I need to check the plot one by one. It costs me a lot of time for determining a single value. Now, you can easily discover the desired value across all the goals with minimum setup work. Meanwhile, to further reduce your amount of manual calculation, custom visualization parameters can now depend on their related parameter. You can just set up the item in the engineering database once, and they are ready to use for past, current, and future projects. After the setup in engineering database, the parameter is now can be used in the study and shown through the plot for further analysis. Now, we have understood the new feature for the simulation and the flow simulation. However, there is still a part of simulation module which will involve in the plastic study, with the injection molding. And I will pass the session to my colleague Fish, the professional in plastic simulation, for this part. Fish.
Hi. Okay. So hi all. This is Fish here, and today I would like to share you all about what's new in the Solar Plastic 2021. Just for your information, there are actually quite a lot of things that has been improved within these new releases. But just for these sharing sessions, I will only pick some from them that I think that it will be helpful on increasing your productivity. So here is the things that I would like to talk. Basically, a new injection process was added, which is a multi-material overmolding injection process. And the plastic material library has some updates in terms of the numbers. The way we define the boundary conditions and domain was enhanced. And the mesh on the sketch-based buffer and bubbles was improved. But talk is always easy, right? So here I would like to show you all the changes in details. So in this SolidWorks 2020, we only managed to apply the injection process for only one type of polymer material in a cycle. But when it comes to the 2021 versions, a new injection molding process was added as what I have mentioned just now. So with this multi-material overmolding, it allows you to apply injection process for up to 6 types of polymer material. And this process will be helpful to analyze the rigid plastic part that will require a self-product covering. So let's zoom into the left hands. And this will be the interface showing the comparison between the two versions about the injection process. The previous version will only fill in the cavity in the same cavity order. But with this newly added multi-material over injection molding process, right, you can selectively choose whether you wanted to fill in the cavity concurrently or in the same time. So let's move on to the next validation step. Usually after we apply the cavity, we apply some other settings. So we will need to launch the material database to select the material we wanted to inject. And for your information, the number of plastic material has added over 300 material. So it is according to the latest data given by the global material manufacturer.
Wait,
And,
Fish,
yes.
do you mean that is increased in 300 of material?
Yes.
So what is the total number in the material library now?
It is about 400 somethings now, because previously it is only got 100 something.
Oh,
yes.
Thank you.
Also, you cannot directly open the plastic, the coolants, and the metal material database before you create any new study. So in the previous versions, we need to physically create a model for the molds. But for now, we no need to do this. Okay, this is because more application has been enhanced by the domain-based material definition in this new release. So once the material for this injection process was specified, you can just apply the material to its associated domains, and then directly jump to define the cooling channel. So for buffer, you can see from this screen, right? A blade was inserted into a channel to split a flow massage, which is here. And for the bubble, an inner tube will replace the blades, which is like this. Also, we can now define the thickness and height for both blade and the inner tube. So this enhancement on the both buffer and bubbles will enable the creation of accurate hexahedral mesh, and this will improve the accuracy of the cooler flow and the mold cooling solutions. So it will also make the simulation looks very, very realistic. And after we have done defining the domain, right, we will then move on to set up the boundary conditions for the plastics. So, within this new release, we can define the boundary conditions geometrically. This means we can actually just refer to the geometry itself to set up the cooling channel inputs, outputs, and also the clamp force of the directions. So this means for this new release, we only need to create a mesh for only one time. And here is the comparison about the meshing process pertaining to the two different versions. So in the past, even though we already create a mesh, right? If we wanted to do some new modification on the boundary conditions afterwards, so we will need to always keep the mesh updated every time. But while for now, even though we already create a mesh, but if we modify the boundary conditions, we don't need to update the mesh, like create the mesh again and again, but we can directly go to run our simulation analysis.
It means the mesh will be updated itself after we apply the boundary condition.
Actually, because previously the things that after we have applied the boundary conditions, right, everything is referring to the mesh conditions. But in this new release, because the things that you set up are only referring to the geometry itself, so the meshing might take some time for you to like resolve to get an accurate result, because everything will analyze based on your meshing. But the boundary conditions you met, right, it will only referring to the geometry. So unless you make change on your geometry, so other than that, you don't need to do anything to update the mesh.
Understand. Thanks for explanation.
Hope you can understand.
Yes.
You really understand it.
Yes, I can understand.
So after hearing all those enhancements of the SolidWorks simulations, floor simulations, and the plastic, right? Most of you might feel excited to test them now, but don't do that first. Aside from those design validation we can do while in our office, I bet most of you might not knowing that actually we also have one good thing that we can do at home using the which is the simulation we can do at home. The good thing is the 3D experience simulations, and it is also as known as Simulia. It was my best working partner while I need to work from home, yet stay collaborated to my colleagues. So what gave me such confidence to say so? Not because I'm kawaii, because using this Simulia, we can do the assisted design validations, the virtual prototyping, and the LS simulations. Actually, these all things we can also do with using any other simulation applications on premise, but with this Simulia we can do on clouds. So I knew some of you might have never used this Simulia. So here I will give you a short tour guide to understand how things work. So let's assume me and Wenzel need to work from home during this COVID pandemic. Okay, this is me. I was a design engineer that has created this Motoni using SolidWorks in my PC. So, but since I currently need to work from home, so I was facing with many difficulties. Like I have always let Wenzel updated with my designing progress because we are working together. And the challenge here is if we are not able to share our files and the project information in real-time basis, so it will lead to a very huge costly conference. And let's assume this is Lee, even though he doesn't have master's, but he will be the analyst engineer. He will run the simulations as we are working together to design the Motoni, right? So he need to keep track and compare what I have done and then run the simulations to test the design model. So to make things easier, I create the model using my SolidWorks, and from here, these right hands, you can see that here's the platform, which is the integrated 3D experience workflow, allowing me to upload my files into our Simulia website when I have done. Okay, so after I done uploaded my model into the Simulia website, Lee will be able to trace the change in my model, and because everything is uploaded into my company dashboard, so he can open the file share and run the simulations on clouds. So this is actually running on cloud because this is a 3D experience platforms. And in this simulations results, it shows that the lower bracket was pressing with the other parts when it moved. So he will then inform me that this part need to redesign. Thus, I will open up my SolidWorks and redesign the bracket using my files. Also, I need to make sure the redesign model will have the expected strength, but I don't sure because I don't have solid simulations in my PC, right? So I will run the simulation using this validation app. This one. So this is the structural designs. This is the linear structural validation application under our structural design engineer role. And from here, I'm just going to let you all know that I'm really never used this simulation apps. So knowledge like FEA, CFD, dynamic force or what, not linear. Actually, I have given back to my lecturers. So yes, really. So everything you ask, I don't know. Okay. However, the built-in assistance makes it very easy for me to apply all of the boundary conditions because only thing I need to confirm is to make sure everything at the left hand will be checked, have a green check, make sure that thing is really applied. So that's how I can do the simple simulations without the need to wake up him in 2 a.m. in the morning and ask, hey, Wenzel, how to write the simulations? Okay. After he will go to the our simulator website and refresh the dashboard. So he will saw that okay, Fish got update some new physical simulation solutions, and he will open it and check and review the result that I have done. So making sure that the boundary conditions I applied is correct. He will now need to compare the redesign model with the previous ones. So instead of the need to rematch the assembly files or apply a new mesh, he can skip everything here. All he needs to do is just open up the original designs and replace the old models with the redesigned models. Then proceed to rerun the study. That's it. So with the results completed, he will compare the two studies. So he can read the strength of the new brackets and compare them side to side. Meanwhile, if let's say I have other colleagues like my boss, I have suppliers, I have stakeholders, they also wanted to know what we are doing right. So he can go to the he can also go to our simulator dashboard and take a look and make a revision on our projects. So my boss will have no reason to deduct our salary because everything will be visible during this COVID pandemic, even though we are working from home. And in brief, this powerful technology for these advanced simulations is what makes me feel very comfortable and confident to work from home. Because this simulator will make a simulation-driven design more powerful than ever, and it also able to provide some realistic and accurate virtual prototyping capabilities. It is also able to do advanced simulation like 3-point bending test, sheet metal forming, hydroforming analysis, and many more. And there are also many other benefits that can be done on clouds using this 3D experience platform. So just for these sessions now, I will only able to show you a brief introduction on how only this simulator works. But if you wanted to know more, know deeply about it, please attend for our next sessions in the afternoon 3 p.m. because my colleague Adam will share more about it. So for now, I will end my sessions with sharing you the last video about our customers, and it is about the similar impact during this COVID pandemic. So let's have a look. This one, okay. Hope you all can enjoy this video.
Well, what's happening in the world right now is something that I think most of the generations that are living on planet Earth right now have never dealt with. We really have to get back to normal and well, fix the situation in some way with simulation. The very first thing we looked into when this pandemic happened was how can we help to create safer spaces to go back to normal. So we worked really hard to take our best-in-class software for transient turbulent flow with particle tracking to model the propagation of the water droplets that would be projected from a sneeze or from coughing in the real world. So, that was the very first step. And then the second step we took was looking into the environment. So looking into an office room, looking into an aircraft cabin, looking into a vehicle cabin, and use this approach to assess, the propagation of the virus within those environments and how to mitigate it potentially by people using masks, by basically, proper behaviors to try to contain a sneeze or a cough, or even just changing design of ventilation system or HVAC systems to reduce the propagation. And we've got some very encouraging results that we shared that were able to be used to make decisions. I think that moving forward, our generation is going to be more careful about the spread of such contaminants, some viruses and diseases. I think that truly we can help making all of those environments better.
Hello, see you all again. Okay.
Yes.
So let's move on to the
Fourth question.
yes.
Okay, so here we have some short quiz about the things we delivered to all of you just now. The what's new in SolidWorks: simulation, flow simulation, plastic, and also simulation.
Yes.
So here goes with the short quiz.
Are you ready for the poll?
So this will be the first short quiz. So
Our first question is which one?
okay, I'll give you a minute. Okay, so we have shown our question. So what in the SolidWorks simulation 2021, the mesh diagonals tools can be used to in which function? So we will give about more 15 seconds maybe.
Sure.
Okay.
Okay,
So how do you feel about this function?
You ask me, I don't know. I'm not very expert in similar like I can explain.
I think you apply this function because in the Simula have automatically assigned in array. Right?
Yes, got.
Okay, so that's right. Okay, so now we will close for the work. Is everyone done your work for this short quiz? Okay, so I will close for it. And now I got the result, and I will show the result to all of you. So this is the full result for this short quiz. So yes, the answer is D, all the above. In the SolidWorks 2021 for simulation, the mesh diagnostics tools can be used to analyze all the result at specific location element, also on selected entities, and lastly, the most important one, isolate the poor quality elements. Okay, so this for this question, we will move on to the next question. It's more related to the SolidWorks flow simulation. So the second question is the plastic one.
Yeah.
Okay, so
Because just now I got shared all about there is a new injection molding process was added into this new release, right? So my question is, what is the name, the correct name for this new injection process? Let's vote for it.
how much time you want to give for them?
This one so easy, 15 seconds lah.
15 seconds.
No, longer, 20 seconds.
Any hints for the audience?
Yeah, I think I shared the question for them already.
Because
collecting the response.
Any hints are okay, because this thing is related to the material, polymer material, but it doesn't have a polymer inside. So guess. I think my hint is too direct.
All right.
So do you think the time is enough already for them?
You all want to keep voting or just end these 4 questions? Okay, so
Maybe
I see
give
there's
them
still
another,
got.
yeah,
Maybe
another
we give
10
them
seconds
about
for people.
Okay, sure.
sure.
I'll give another 10 seconds. I see still got somebody. Still got somebody is voting for it. Okay, let's see. Who?
Okay, I think we can probably stop the poll already, right?
Okay.
Let's
So I will end the post and I will show the result.
Yeah. Actually, the correct answer will be the A. Multi-material overmolding doesn't have polymer inside. Yes, no polymer inside. Okay.
Okay, I think then.
What is the next 4 questions, go?
No, this 2 is all. Do you have any more question for our customer?
I don't have. So far, I don't have. But if you have any questions, you can leave in our questions our questions columns.
Then we will answer your question.
All right, yeah. Actually, I think we do have some questions right here. There's one right now. The question is from Mr. Lu Fu Hong. Hi, good morning.
Okay.
How can you
morning.
determine the, yeah, so this is the question. How can
Okay.
you determine the simulation would be similar to the actual testing product performance? Is there any preset template or material in this cloud system? So it's regarding the cloud.
Okay. Actually, for every simulation results, right, is actually need to do the comparison with between the prototype and the virtual prototype you do on, whether you do on premise or do on cloud. And the accuracy, because of we do, it is due to your parameter settings, the boundary condition you set, and then you need to compare with the real, the realistic product. But maybe you can use a prototype. If you have enough, you get enough information and you're able to do complete all of the considerations inside when you are setting up all of those boundary conditions. So the result will be the correct one because all of the solver, the simulations of mathematical solutions or the FEA solutions is actually what you are using in your real life situations.
I see. All right. Yep. Thank you for answering.
Yes.
So far we only have that question. I think some of you may have some difficulties hearing us. Can you guys hear us? The audience, probably you can put it in the chat or on the question. Testing 1, 2, 3. Is that okay?
Can you hear us?
Well, I can. But
Yeah,
all right. Yep. Right. So currently there's no other questions as well. All right. Yep. Can hear. All right. Thank you, Sharon. Thank you, Kaiser. All right. Yeah. So are there any questions for this session? Yep. Thank you so much for responding. Yeah.
Any more question for us to answer your any thoughts?
All right. I think so far not yet. Right, no other questions. But what you can always do is actually, if you have any questions in regards to simulation or the cloud platform, for the cloud platform, obviously we have a session later on at 3 p.m. to 4 p.m. where we will be talking about more on the cloud integration. Yeah, but if you do have any questions other than that on the plastic simulations or like the CFD and also the CAE or FEA simulations, all those, you can actually write into us at info@CADVision.com.my or .sg, depending on your location, and we will be getting back to you from there. All right. Yep. So for now, thank you so much, Fish and Windsor. Yeah, thank you for the
Thank you.
insightful explanation on the new features of SolidWorks 2021 and as well as the cloud platforms functions. All right. Yeah.
Okay, thank you.
Thank you for hearing.
Yeah, thank you for having.
No worries.
Bye.
Thank you for joining us. All right.